Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and PaintballProps.com. Today we're going to put together one of the Arduino compatible Ultimate Multi-Program laser tripwire sets. This is what you will get. All of these components, we'll go over them in just a second. What is not shown here is the wireless receiver, which comes with some options so you can wirelessly activate and deactivate. We'll do that at the end. Some kits will come with the wireless receiver and transmitter. Some kits won't, depending on what you've pledged for in the Kickstarter below. In any case, let's get started. This is the custom PCB. 2 470 ohm resistors, 15 10k ohm resistors, a 7805 5-volt regulator, 6 ceramic 0.1 microfarad capacitors, 2 electrolytic 100 microfarad capacitors, a 1N4001 diode, a DC power jack, momentary tactile push switch, programmed PIC 18 chip, 18-pin socket, DIP, 5-volt relay, audio connector, 5-pin, 4 light-dependent resistors, or LDRs, a 2N2222 NPN transistor, 5 3mm red LEDs, 3 jumpers, 1 6-pin header, 1 2-pin header, 1 3-pin header, and 2 4-pin headers. Now, first of all, what we're going to do is we're going to connect our resistors. Each resistor placement on the board, or rather silkscreen, has a name, such as R1, R2, and R3, and it also has a value, such as 470R or 10K. So we've got 15 10K ohm resistors, 2 470 ohm resistors. The 2 470 ohm resistors are placed here, R17, 470R, and R11, 470R. All of the rest of the resistors, such as R12, 13, 14, 15, 16, 5, and 3, also R4, R12, R9, R7, and R8, and R10, they are all 10k ohm resistors. Make sure you don't mix them up. Place your 10k or your 470 ohm resistors first, just to get them out of the way. Then you'll know that every single resistor left on the board is 10k. There's no polarity. Solder them in either way. I suggest making them flush to the board, making it look neat. Take care with your solder joints. Make sure that your solder joints are good. They're not cold solder joints, and that you don't encounter any shorts as you move along. Now we'll place the capacitors. First, let's start with our ceramic capacitors. They're all labeled 104, and that stands for 0.1 microfarads. They're ceramic, so they're not polarized. Both leads are the same size, so you don't have to worry about reversing polarity. Place those capacitors in the C6 slot, C7 slot, C9 slot, C4 slot, C10 slot, and C3 slot. Once you're done that, let's talk about the electrolytic capacitors. The electrolytic capacitors have a long lead and a short lead. The long lead is positive, the small lead is negative, and you want to make absolutely certain that you do not mix polarities here. They go into the C5 slot and the C8 slot. Now, if you look at C5, there's a little plus sign facing the bottom of the board. So that means that the lead facing the bottom of the board, the little hole there, is where you want to place the long lead of the capacitor. Place your short lead in the upper hole of C5. And as for C8, the positive is on the right, so long lead on the right, short lead on the left. If you solder these in backwards and you power it up, you'll pop the capacitors, and they might cause an internal short, and they certainly will not work, and that can cause the board to malfunction. So make absolutely certain that you place those in the right way. Once we're done soldering all of these capacitors into place, we're going to solder our diode, our button, and our transistor. This is an easy step. The button goes in the cell slot. Now, it only fits in one way. There's 2 leads on the left, 2 leads on the right, and there's a substantial space in between. Pop it into place. Once you line up the holes, it should just pop in. Make sure that it's flush to the board when you actually solder the 4 joints. The diode right here, the 1N4001 diode, goes in the D1 slot. Now, notice on the diode that there is a white stripe on one side, and the other side is completely black. The white stripe side is your negative or cathode, and the black side is your positive or anode. And in the D1, on the D1 footprint, there's a white stripe facing the bottom lead. So place, from a bird's eye view, make sure that the white stripe on your diode is facing the bottom pin, and that your black side is facing the top pin. If you reverse the diode, what will happen is as soon as the relay turns on to activate the siren, it'll cause a short circuit and reset the system. The transistor, the 2N2222 NPN transistor, goes in the T1 slot right here. Now the T1 slot, the silk screen has a flat side and a rounded side. The transistor itself has a rounded side, it'll rock back and forth on it, and a flat side with writing on it. Make sure that from a bird's eye view that the flat side is facing the bottom and that the rounded side is facing the back from this perspective. The middle pin is at the top middle. Of course, the left and right pins are left and right. I hate to have to add that in there because it's pretty self-explanatory, but I have had questions in the past, so I just want to make sure that you solder that component in correctly. Now once you solder those components in and you've made sure that the polarities are correct, then we will do our 5 LEDs, our audio connector, which will connect to our siren, and our DC power jack. The DC power jack goes in the DC jack slot. It only fits in one way. We want to make sure that the side where the power supply is connected is facing outwards, and it should fit right into place. Make sure it's flush to the board when you solder it in. Don't apply too much heat at one point. Basically, you just want to make sure that each pin is connected to the pad. Then you can add a little bit more solder to make sure that all the gaps are filled. But I'm just saying don't add too much heat at one period of time, or else you might melt the connector. Same goes for the audio connector. It has 5 pins, 4 on the bottom, 1 on the top. Now, it's labeled on the board siren. Just make sure all the pins are straight, and it should fit into place quite nicely. Make sure it's flush to the board. Don't apply too much heat at one time. If you've got a decent soldering iron, you should be able to solder each pin fairly quickly. You just don't want to make sure that you don't apply too much heat for a long period of time, because again, you can damage the connector. But that goes with most of the components. They all you don't want to add too much heat for any long period of time, or else you could potentially damage them. In any case, let's move on. The LEDs go in the indicate slot. The LU, D, and R slots as well. And LU, D, and R stand for left, up, down, and right. Now, each LED has a long pin and a short pin. Sorry, it's off screen. Like the diode, the long pin is your positive or anode. Your short lead is your negative or cathode. Now, in the case of indicate, you want to place your long lead on the bottom pin and your short lead on the top pin. If you reverse that, your LED won't work. In the case of the LU, D, and R LEDs, the long leads or positive leads go in the bottom, and your short leads all go in the top. Long leads in the bottom, short leads in the top. So solder those into place. Again, if you reverse them, you won't cause any problem to your circuitry necessarily, but your LEDs won't work. So solder those all into place, and next we will do our pin headers. The headers can be a bit of a pain because you can burn yourself if you don't know how to do them right. But I'm going to teach you a little bit of a cheat. Let's talk about our smaller headers first. Our 3-pin header goes in this slot. Our 2-pin header goes in the LED enable slot, LED EN. Our 6-pin header goes in the output slot right here. And our 2 4-pin headers go in the program select slot. So what we can do is we can use our little jumpers to help us to keep from burning our fingers, because you have to hold it in from the top of the board. I usually use my nail, but I don't have long nails, so sometimes I end up burning myself because heat will transfer through the bottom into the top and burn your finger. And that can be a pain unless I've mastered the art of it. Well, I shouldn't say mastered. I'm pretty good at it without using the headers. But what you can do is you can put the 2-pin jumper over top of any one of these headers, place it in, make sure it's flush to the board, hold it down, and then from underneath solder 1 pin. After you solder 1 pin, go back to the top to make sure that it's flush to the board, and then solder the other pin. Then make sure that both have a nice solder joint. You can do that for the, sorry, I have the relay holding this up, for the 3-pin header and for the 6-pin header. But here's a neat one for the 2 4-pin headers. What I like to do for the 2 4-pin headers is, and again, sorry my hand's getting in the way, it'll all become clear in just a second. Place them both in to the slots, the top and bottom. Then I take a 2-pin jumper, connect one of them together so that now they're uniform with each other. Then I hold it down, solder one of the outside pins, just one, making sure that I don't cause any shorts. Then bring it back, make sure it's flush to the board, and then I solder the remaining 7 pins. So there, it's actually very easy. If you have a board with the wireless connector option, you may or may not have that. Just ignore that slot for the time being. And after this step, what we'll do is we will solder our relay, our socket, and our LDRs. And from there, we'll almost be done. We're actually going to connect the LDRs next. What I want to mention before we connect our solder in the socket and the relay is we have those 2-pin header jumpers. Make sure that you, for the time being, you place one on the LED enable pins, one on the program 1 set of pins, so the pins on the right, because we're going to test this unit in a minute in gesture mode. And we also want to have one of the 2-pin jumpers on the VCC and enable pin, or the middle and left pins. So as for the socket, if you look closely, you probably can't see this in the video. One side of the socket has a little notch right there. Pay close attention to that notch. There's also a notch on the left side of the footprint for the chip. So from a bird's eye view, make absolutely certain that those notches align with each other. So the notch is on the left. After you solder it into place, the microprocessor, the PIC-18 chip, has a notch on the left hand side too. Make sure that after you've soldered it in that you connect that into the socket with the notch facing the left. If you power it up with the notch facing to the right, it's going to cause a huge short circuit and it can completely fry your microprocessor. So make sure, absolutely certain, that your notch from this perspective is facing the left. As for the relay, very easy step. There's 5 pins on the relay. There's 5 pins on the relay footprint, 3 pins on the left, 2 pins on the right. It should fit right in as long as the relay leads are straight. If they're not straight, simply bend them out a little bit and it should fit nicely into place. Make sure it's flush to the board and that you add a lot of, a solid amount of solder to each lead, because the pads are very large. You want to make sure that it flows on nicely. So solder those all into place. Then we will do our LDRs, and lastly we'll do our 7805. I shouldn't say lastly because we'll also add the wireless option for this specific video. The LDRs go in the down, left, up, and right slots. Now you don't want to place them flush to the board. If you do that, they'll likely be damaged when you solder them into place. What you want to do is place them about 1 centimeter off the top of the board. 0.75 centimeters to 1 centimeter above the board. Solder them into place, make sure that they are level, and they are all level with each other. That way, it's a nice cosmetic thing. The 7805 goes in the slot right here, labeled IC2. There is a grayish white side, which is the back, and the front side, which is black and has writing on it. Make sure that the black side with writing on it faces the DC power jack, and that the white side or gray side faces the back of the board, like so. Place it in. It won't go all the way down, which is perfect. Just make sure that it's down far and that it's standing straight up. Be careful when soldering the pins in, because it's a little bit easy to do some shorting. Just make sure that you have no shorts, because that's a very, very, very important component that regulates the incoming 9 volts to 12 volts down to 5 volts for the digital circuitry. Solder those all into place. I'll show you what it looks like in just a second. And then lastly, for those of you who have a wireless receiver and transmitter, I'll show you how to connect that. The wireless receiver has 7 pins, and it fits in this slot right here, right below the relay, with the long side facing right. So line up the pins, make it flush to the board, make sure it's standing straight up, and solder each pin into place. Make sure there are no shorts. After you solder that into place, if your kit includes a wireless receiver and a transmitter, then solder that into place. If it doesn't, we're still going to test all functions after this. If your Kickstarter pledge did not include an AC adapter, you need an AC to DC adapter rated for 9 to 12 volts out at 1 amp minimum. So the first thing we're going to do is we're going to test all of the LDRs. So to do that, we have to have the LED enable jumper shorted with a 2-pin jumper, and we're going to place ourselves into program 1, which is gesture. So I'm going to take my AC adapter, plug it in, and we'll know if everything's working by the state of the LEDs. So as you can see, the left LED lights up. The up LED lights up. Let's test the bottom. The bottom LED lights up, the D down, and lastly the right. So right. It works. So all of the LDR circuits are functional. Great news. So next let's test our siren. Some pledges will come with the loud siren, and what I'm going to do is I'm going to cover the siren up for the test because it's extremely loud. I'm going to take the connector, connect it to the audio block, and as for the jumpers, you can remove the LED enable jumper if you want. It doesn't matter. I've changed the program select from program 1 to program 4, which is laser Tripwire 2, and now I'm going to plug it in. Wait a second, and I'm going to press the first I'm going to cover the siren. Now I'm going to press the cell button to activate. So it's activated, and the LED indicator is on, telling me that the system is active right now. I can press the cell button again to deactivate it, but let's test the siren. Now you can have up to 1 or 4 lasers on that if they detect quick changes in light, so I just used a shadow in this case. It is meant to have lasers on anywhere from 1 to 4 of the LDRs, but in any case the next revision, the last revision of the user manual, the video user manual, will be done in about a week. So don't worry about that for now. We're just testing all of the peripherals, or the peripheral and all of the functions on the board. So the LDRs work, great. All of the LEDs work, great. The siren works, great. I'm going to remove power, and what I'm going to do is I'm going to have my wireless transmitter handy, and because we have the wireless receiver connected, what I can do is power it on and then immediately press and hold the cell button. After a second, let go. As you can see, the LED is scrolled right 3 times, and that tells me that wireless control has been initiated. So before, the wireless receiver would not be able to communicate with the board, or rather it would communicate with the board, but it wouldn't be processed. So now we can use either the cell button, or I can use the wireless transmitter, press any button, let go, and it wirelessly activates. If I press it again and let go, wireless deactivation. So if I won't cover the siren this time, what I'll do is I will press a button, let go, activate it. I'll trip one of the LDRs, and I'll deactivate it wirelessly. So the neat thing about the wireless transmitters is if you're feeling ambitious, you can gently open this up, reveal the battery and the buttons on the board. Solder a bigger button in parallel, put it in a project box so that you can have a bigger button on the project box to be able to wirelessly activate and deactivate it. But you can put it on, you can put your keys in the keychain, you can put your keychains in the same place. I'll activate again, and I'll deactivate again. There we go. So everything works. The wireless receiver works, the board powers up and processes nicely, all of the LEDs work, the siren works, we're in good shape. So those are all tests that you should go over when you're building your unit. Whether or not you have a wireless receiver doesn't matter, because as long as you don't hold down the cell button during power up, it won't enable wireless control. Now let's assemble our 3-volt regulator PCB for our lasers. This is your custom PCB, single pole double throw switch, two 2-pin terminal blocks, a 0.1 microfarad electrolytic or ceramic capacitor, two 100 microfarad electrolytic capacitors, a 330 ohm resistor, and a 240 ohm resistor. So first of all, let's connect our two resistors. Your first resistor, R1, is labeled 240 ohms, 240R. So place your 240 ohm resistor in that slot. Place your other resistor, your 330 ohm resistor, in the slot. Don't mix them up. Once we're done that, we'll do our three capacitors. The single ceramic capacitor goes in the C3 slot right here, labeled C3 0.1U. Both leads are the same size. It is a ceramic capacitor. There's no polarity. Just place it in either way. After you're done that, we're going to connect or solder in rather our two 100 microfarad electrolytic capacitors, and they go into the C2 slot and the C1 slot right here. Now, in the case of both of these capacitors, the positive leads go in the bottom holes and the negative leads go in the top holes. From this perspective, the long leads are the positive of the capacitor, the short leads are the negative. Both of them have a polarity. You want to make sure that you connect them right the first time, or else when you power up the board, you'll damage the capacitor almost immediately. So again, long lead in the bottom holes, short leads in the top holes. Sorry, it fell there. And you can actually see a little positive sign, a little plus sign on the two bottom leads. So make sure make sure from this various perspective that you don't reverse polarity. Next, we'll do our switch, and then we will do our terminal blocks. From this perspective, the switch area is right here. Now you'll notice a little notch right there on the right side of the switch silk screen, a little notch. Now on one side of the switch, there's a little notch right in the middle. You want to make sure that from this perspective that notch is facing the right side of the board. So you have to place it in from a bird's eye view with the notch facing the right side of the board, and that is our on-off switch. Be careful when you put it in, and be very careful when soldering the three leads in the middle, because you need a nice soldering iron to get those without shorting each other. You won't damage anything if you short them together, but if you short pins together, but the device will likely always be on if you do, and the on-off switch is obviously used to be an on-off switch. So after this, we'll do the terminal blocks, and then we'll do our LM317. The LM317, which I completely forgot to add in during our introduction, is a 3-pin variable regulator that we use, that we have basically set to 3 volts out using the 240 and 330 ohm resistors. We'll do that last, but what we're going to do first is we're going to take our terminal blocks. Now the terminal blocks have a plastic side and a terminal side. You want to make sure in both cases that the terminals are facing outside of the board when you solder them into place. If you have them facing in, then you're never going to be able to wire your input and output terminals, your input power supply and your output to the laser. Now, I want to mention also that on the outskirts there are soldering holes in case you don't want to use the terminal blocks. The LM317 goes in the middle footprint, and as you can see from this perspective, on the footprint there is a white side on the back, and on the very bottom, on the bottom side, or left side rather, it says LM317. What you want to do is, there is a white side of the LM317 and a black side. You want to make sure that the white side of the LM317 is facing the switch. If you turn that around, your circuit will not work. So just like that, facing the switch. Solder it into place, solder your terminal blocks into place, and next we'll test it. In the case where you plunge towards an AC adapter, a 9-volt AC adapter for your regulator board, what you need to do is cut off the DC jack at one end and expose the red and black wires. And once you do that, connect the red wire to the in plus terminal and your black wire to the in minus terminal. Once you've plugged in your AC adapter, then you want to place the switch into the on position. Take your red probe from your multimeter and connect it to the 3-volt pin, and your negative to the GD pin for ground, and it should read roughly 3 volts. So 3.04 volts. Perfect. Now let's connect a laser to it. I've connected the red wire from the 3-volt laser to the 3V pin, and the black wire, which is the negative wire on our laser, to the GD pin. Now what I'm going to do is I've still got this switch in the on position. You can turn it off if you want. I'm just going to, well, actually what I'll do is I will turn it off, just for the sake of turning it off. I'm going to plug it in, and I'm going to turn the switch on. Now my laser can be powered by anywhere from 4 volts to 15 volts DC. So there you go. Thanks for watching, guys.